Now we are discussing about the decimals. When the difference between two adjacent whole numbers is divided into 10 parts or any multiple of 10 in bracket, that is 100, 1000, etc., that difference may be expressed with a decimal fraction. A reference mark called the decimal point or denoted by point is used to indicate the difference between whole numbers and decimal numbers. The whole number is placed to the left of the decimal point and the fractional amount to its right. Thus 3 by 10 equals to 0.3. Both read 3 tenths. 3 by 100 equals to 0.03. Both read 3 hundredths. Now 3 by 1000 equals to 0.003. Both read 3 thousandths. Decimal fraction provide a means of performing mathematical operation without the necessity of using the time-consuming and complex methods of complex fraction. Here we divide numerator by the denominator. Example, take 2 by 3. So when we will multiplying 3, we will divide 2 by 3. Then it is, since 2 is less, we will put a decimal and 2 will become 20. Then we will divide it by, and then we will multiply 3 by 6. We will get as 2. So 0.666, and this will be a recurring of 6. However, these all not given in book, but may be given in some books which I am not referring. 0.66 and so on. Now here in the above example which we have discussed, the 6 comes several times. However, after possibility is also there when we take other example. Here 6 is in the 10th place and 100th place and so on. If the nearest 10,000 asked, we will write 0.6666. Before this, let us take easy one. Now you are dividing 29 by 45. So you get 0.644. Again 44 is repeated. So it is less than 5 and it will be round by 5. Now take another example of easy one to understand and convert half fraction to decimal. For example, take 2 dividing 1. So how it will be divided? We will put point. Thereafter we will multiply 2 into 5, which will give 10, and there will be no remainder. So it will be written as 0.50. Zero after decimal can be followed by the first digit only if it comes and does not have any value, but here 2 is dividing 1, so it is half of 1, means 0.50. Pure decimal. A decimal fraction that is written in the whole number as 0.0, 3.3, etc. is called a pure decimal. Mixed decimal. When a decimal fraction is with a whole number such as 2.3, 8.03, etc., these are called mixed number. Rounding of decimals. We have seen the decimal value comes in a clumsy manner, so it is to solve to get a precise to some extent. However, it is impractical but not impossible. For example, 30.6968 inches has come in measurement, and this is not to be measured with a steel rule, which is accurate only to 1 by 64 inches. So rounding comes in pictures. A decimal expression is rounded off by retaining the digits for a certain number of places and discarding the rest. The retained number is an approximation of the computed or exact number. The degree of accuracy desired to determine the number of digits to be retained. When the digits immediately to the right of the last written digit is less than 5, leave the last digit retained. For example, round 31.4747 to the nearest tenth. First, determine the number of digits to retain. In this case, 1/10 being the first place to the right of decimal. So 31.4747, we can write 31.47. So as we see, 7 is greater than, it will be written as 31.5 to the nearest tenth. Now converting common fraction into decimal. A common fraction can be converted to decimal by simply dividing the numerator by denominator. For example, 4/7, or we are dividing, or it means 7 is dividing 4. So how it will be dividing? First you see 4 is less than 7, so we will put a decimal to make it 40. Then after we will divide by 5, multiply by 5, you will get 35. Then subtracted, you will get 5. Now it is also less than 7, so we will bring another 0. So now we will multiply by 7 into 7, we get 49. Then again as a reminder as 1. Then we will take 0 again. So this will becomes 7 into 1, 7. Now it is 3. So last the answer comes, which we have done is 0.57042 and so on. Here rounding off can be performed as per ours. Now decimal to common fraction. Let us take an example. 0.6, 0.05, etc. 0.6 can be converted to 1/10 or 6/10, which is also equal to 3/5 after cancellation. Similarly, we go for 0.05, which is 100th of 5, or 5/100 equals to 1/20. Now we will see addition, subtraction, multiplication and division, the basic tools of mathematics applied on decimal. How we do addition of decimal? We have discussed earlier about this, but this is a specific ongoing lecture of addition and subtraction of decimal. We have to put the decimal fraction aligned with another number. For example, 32.486, and we are adding it with 4.325. So 32 and 4 is the whole number, and 0.486 of one number and 0.325 of another number is decimal number. So first we will add the decimal number 651 and left 1, so 8192, again 1 is again has come in hand, so 437 and 18. Now we will go for the whole numbers. Here if the decimal numbers gives a hand for the whole number, that will be also added, but in this case there is no some in hand to come in whole number. So what we do, it will come when it is more than 10. It is equal to 10. Now we are adding 4 and 2, it will be 6, and 3 6, and the result will be 36.811 on addition. Now subtraction is also in the same manner between two numbers, and it will be arranged so as it was arranged in case of addition. Now take the same number 32.486 and minus 4.325. The result is 28.161. In both the numbers are arranged vertically, that is whole numbers in one part and decimal number in the respective places. Division of decimals. In this case, a special care is to be taken, then addition, subtraction and multiplication. This is because it is easier to misplace that decimal point in the quotient. The principal rule to remember in dividing decimals is to place the decimal point of the dividend. Example, 436 is to divide 0.0896300. Now we will divide it we get the last value. On rounding of decimal is applied to the 5 to the provide and accuracy to nearest 10 millionth is 5. You divide it, you will get in 10 millionth is 5. When the divisor contains, I'm not going step by step for all things solving and that. You just solve it and you will get the 5 to provide an accuracy to the nearest 10 millionth is 5. Now, when the divisor contains decimal, we move that point to the right until the divisor is a whole number. We then move the decimal in the dividend, the same number of points to the right. This is equivalent to multiplying both the dividend and the divisor by the same number, and so the quotient remains the same. Divide 8.624 by 36.035. No, 36.035 to be divided by 8.624. We will remove decimals from 8.624 and it will become to a whole number 8634. Similarly, we will remove decimal from 36.035. It will be 36035. Simply we will divide it, so remainder will be, so the remainder and quotient will be something like that, 4017 plus rest. Now you take an example for your practice. Divide 54.932 by 4.03, 92.562 by 6.08, 87.432 by 4.35. Converting decimal to common fraction. It has been stated that decimal is a fraction, and of course this is time, and this is true. And decimal fraction is a fraction that has 10, 100, 1000, etc. for the denominator. The decimal 0.72 is read 72 hundredths and may be shown as 72 by 100. Let us take an example. Convert 0.325. 325 divided by 1000 divided by 25 upon 25, we will get as an answer 13 by 40. Now convert to 0.625 to a fraction. We divide as follows: 625 divided by 1000, dividing again by 125. By 125 we will get the value as 5 by 8. It is obvious that many decimals cannot be converted to common fraction because the numerator and denominator may not have common factors. However, it may be possible to arrive at an appropriate fraction which is within the accuracy limits required. For example, 0.3342 may be converted approximately 1 by 3. Now practice. 8.035 divided by 320. You are dividing by 320. Now number 2, 6752 5.2 divided by 0.054. Third, 1.032 you will take a multiplication sign. Now 0.0544. Now fourth question is 628.12 multiplying 4.02. Now fifth is 62.5 divided by 0.03. Now sixth is 9.875 dividing by 64.82. Now convert to decimal. It's a problem. Now seventh is 8 by 9 for practice, and 8th is 4 by 7, 9th is 3 by 8. Now you have to convert to fraction. Now 10th number question is 6.025. 11th is 3.329. 12 is 8.752. Now this is all about the decimals. Now we are going for a scientific notation or the powers of 10. In engineering and scientific calculation, very large and very small numbers are involved. As you will go through, so to make it easy for manipulation and decrease the possibility for error, scientific notation, commonly called the powers of 10, is used, and it is a device which is known as exponent. Question: how we write the exponent? Answer: the exponent is a number written to the right and slightly above the number to which it applies. Number written in the right is called base, and power to be exponent. It is of two types. First, it is a positive and another is negative. For example, 6 to the power 2. Here 2 is an exponent, where 2 is positive, so we will multiply 6 two times, 6 into 6, which will be equal to 36, and so on. Let us take an example of negative exponent, 2 to the power minus 3, or it in negative terms, so it will the reciprocal of 2. So how it is? See, 2 to the power minus 3, or 1 divided by 2 to the power 3. Now 1 by 2 into 1 by 2 into 1 by 2 is to be multiplied. So ultimately we will get an answer 1 by 8. Now second, any number can be taken as exponent, but in the case of 0 it is considered as 1. For example, 2 to the power 0 is 1. Now number 3, when a number is written without an exponent, the value of exponent is assumed to be 1. 4, if the exponent does not have a sign plus or minus preceding it, the exponent is assumed to be positive. Now scientific notation. Previously we discussed how we change into a number greater than 1 or equal to 1 and less than 10 by moving the decimal point in the appropriate direction, there with the aid of scientific notation. Let us take an example to understand 3.620000. We can change into 3.62 by moving the 6 places to the left. Now by scientific notation we can write the same value as 3620000 equals to 3.62 into 10 to power 6. Let us take another case in which a number on which we are working is less than 1. Here decimal point is moved to the right. For example, 0.0000002, which will equal to 2.0 into 10 to the power minus 6. Now multiplication by scientific notation. Let us understand by an example. Multiply 0.374 into 4000. Using scientific notation, as we see, 0.374 is a small number and it is less than 4000, which is larger number. Now let us solve step 1. Convert this scientific notation. 0.374 can be written as 3.74 into 10 to the power minus 1. 4000 can be written as 4 into 10 to the power 4. Now step 2. Multiply the numbers. 3.74 into 4. That is equal to 14.96. Now step 3. Now add the exponents. 10 to the power minus 1 into 10 to the power 4. So it will be equal to 10 to the power minus 1 in bracket plus 4. That becomes 10 to the power 3. That means 4 is subtracted by 1. You will get the 3 as an exponent of 10. Base is here 10. Step 4. Assemble the product 14.96 into 10 to the power 3, which will be equal to 14.960. Now third is division by scientific notation. Let us understand by an example. Divide 3.250 by 0.65 using scientific notations. Step 1. Convert to scientific notation. 3250 equal to 3.25 into 10 to the power 3. 0.25 equal to 2.5 into 10 to the power minus 1. Step 2. Divide the numbers. 32500 by 0.25, which will become as 1300 as a result. Step 3. Subtract the exponents. 10 to the power 3 minus 10 to the power 1 equals to 10 to the power 2. Assemble the quotient 1300 into 10 to the power 2, or you can also write 130000. Sign numbers. In a number line in which 0 is a reference point and towards right is positive numbers and towards left it is negative numbers. Positive numbers is identified by plus sign and negative numbers is identified by negative sign. Here one thing more, if there is no sign, it is considered as positive. Now first, addition of sign numbers. Case 1. When we are adding the two positive numbers, to find the absolute value, place the same sign and we will get a result as in positive. Case 2. When we are adding and subtracting with a positive number and another as negative number, we find their difference and the sum comes positive. Number 2. Subtraction of sign numbers. As we have read how we subtract the number to be subtracted is called subtrahend, and from which it is subtracted is called minuend, and the result is called difference. Here take an example to understand it more. Take minuend as minus 345 and subtrahend as 43. Now arrange it vertically. What we will do subtraction, so we will put a sign of subtraction, that is minus in front of subtrahend 43. So when we do this, we get minus 345, minus will get cancelled and it will become plus 43. Now we will just subtract it. We will add it. So it will be 388, but the sign will be of minus because the larger number is 345, which is negative. Now finding the percentage of number of another. Here the partial number 2 I've just gone on percentage. No, first, before that there are more things to be discussed. Multiplication of sign numbers. As we do multiplication of numbers, it is same, but there are rules to be followed by sign numbers. First, the product of two positive numbers is always positive. 2. The product of two numbers is always positive. 3. The product of a positive and a negative is always negative. Example, 3 into 4 equals to 12. 4 into minus 3 equals to minus 12. Now third is minus 5 into minus 4 equals to 20. Minus 3 into 9 equals to minus 27. Now fourth, division of sign numbers. It is also like multiplication of sign numbers, and it is accomplished in the same manner as any other number or fraction. The quotient must be given by the following rules as similar to multiplications. Number 1, the quotient of two positive numbers is always positive. Number 2, the quotient of two negative numbers is always negative. Number 3, the quotient of a positive and a negative number is always negative. Now come to a new topic. Before that, there are many practice problems in several books. You go for that for the significant figures, and those till I have given you the lecture of number system, other topics, and also the coming topics such as percentage, ratio and proportion, and more. Now percentage are special fractions whose denominator is 100. Now decimal fraction is 0.33, is the same as 33 by 100 and may be expressed as 33% or 33. It has got a percent sign that is splitting a slash, and then upper one is point, and below that is also a point. Common fractions may be expressed as percentages by first converting them to decimal fractions and then multiplying by 100. In bracket, move the decimals 2 places to the right. That is 5 by 8 expressed as a decimal is 0.625 and is converted into percentage by moving the decimal 2 places to the right and becoming 62.5%. Now we will discuss the three cases in percentages. Number 1, finding a number which is given percentages of another. Understand it by an example. Let us take to find 33% of 1000. So 30% will be converted into decimal as 0.30 and then it is multiplied by 1000, which will be equal to 300. Now 2, finding what percentage one number is of another. Here the partial number to be written as the numerator and whole number as the denominator and converting them into decimal and to make it multiply by 100, which will give a percentage. For example, the partial number we take 325 above as a numerator and 4500 as a denominator. So here the value comes 0.36. Now it is 36%. We just be put to the left to the decimal. It is 36%. Now number 3, finding the total numbers when part of the number and its percentage are known. In the case, the percentage is expressed into decimal form and then divided by the known number by the decimal expression. Here care is to be taken to identifying the sort of problems and to divide, as the most common error is multiply instead. If 3120 RPM is 32% of the maximum speed, 100%, what is the maximum speed? So we take 3.120 in the numerator and 32 in the denominator, 0.32. Now it will become 97.5. So it will be 97.5 into 100, which will be equal to 9750, which is RPM maximum. Now there are many practice problems which you have have to go through the every thing, such as there are problems on percentages also. The question 1 is 40% of 100. Similarly, what percent of 340 is 90. Third is 43 is 52% of what number? Number 4 is a word problem. If you have expense of rupees 5,000 monthly from your salary of rupees 20,000, how much you save as a percent? Now, ratio and proportion. It could be better understood by an example. Let us take one number, a set of 2 engines, and another has 3. So the ratio will be expressed as 2 by 3 or 2/3 or 2 by 3. So we see it is again a fraction, and it may also be used as mathematically as a fraction. Another method is to express as 2:3, means 2 and putting 2 dots above and below and then 3. It may also be reduced it to the lowest term. For example, 34:51 or 34 divided by 51 as a fraction, we get 2 by 3 or 2:3. A ratio may be reduce to its lowest terms in the same manner as a fraction. For example, 24:36 may be reduced in 2:3 by dividing each number by the ratio by 12. It may be further clear by if in a certain shop in a day, then for clear by an example, in a certain shop one day there was 60 customers and then the second day it is 80. So 60 is to 80 or 3 is to 4. Now comes to proportion. It expresses the equality between two ratios. For example, 4 is to 5 equal to 12 is to 15. This may also expressed as 4 is to 5 equal to 12 is to 15. Or earlier what I said, there are two ratio signs such as 4 is to 5, and between 5 and 12 there are same sign with the ratio 1, but towards 5 is a 1 ratio sign and towards 12 it is a 1 ratio sign. Here in the above problem of proportion, the outer number is 4 and 15 are called the extremes, and the two inside number, that is 5 and 12, are called means. In any ratio, the product of the means is equal to the product of the extreme. Let us by an example. 5 into 12 equals to 4 into 15, which is equal to 60. We may use the above rule and find an unknown term in a proportion. 6 is to 16 equal to 9 is to what? Using x to denote the unknown quantity, we can say 6 into x divided 16 into 9. Thus 6x by 6 and 16 into 9 comes 144, and it is to be divided by 6, or 6x equal to 144. Then x equals to 24. We can prove the foregoing answer by using it in the original proportion. 6 is to 16 equal to 9 is to 24, or 6 by 16 equal to 9 by 24, which comes 3 by 8. Now there is a practice problem. Find the unknown quantities. Number 1, 2 is to 4 equal to 6 is to what? Number 2, what ratio 12 equal to 5 is to 30. Now the roots. The difference between the power and root. In the case of power, the base was written in the right side, an exponent above it. But in the case of root, a radical sign is used. Under it, a number is placed. Example, root under 27 and 3 was on the other side as an exponent. The number of extracting large number is not much difficult, but it requires careful attention to procedure. For example, exact the square root of 104.976, which you could work out, or you can refer a book in which this example is given. Power and roots of fraction. Similarly, we first multiply the numerator as much number by times of each square value in numerator and denominator, and thus we get powers and root of fractions. Now using power of 10, why we use this, all we discussing. See, first, in a positive one, 10 to power 0, which is equal to 1, 10 to power 1 equal to 10, 10 to power 3, which is 1000, 10 to power 4, 10,000, 10 to power 5, 1 lakh, 10 to power 7, 10 to power 6, that is 10 lakh. Now we cannot go for 10 to power minus 0 because minus 0 is vague. Now 10 to power minus 1 equals to 1 by 10, 10 to power minus 2 equals to 1 by 100, 10 to power minus 3, that is 1 by 1000, 10 to power minus 4 equals to 1 by 10,000, 10 to power minus 5, that is 1 by 1 lakh, and 10 to power minus 6 equal to 1 by 10 lakh, and so on. It expresses large numbers or very long decimals. We can shorten the expression and also reduce the amount of computation necessary for multiplication, division, extracting roots, etc. For example, 20,000 can be expressed as 2 into 10 to power 4. And for the extraction of roots with powers of 10, root under 16 000 the exponent is 10, so it can be written as 16 into 10 to the power 6. So it will be ultimately come 4 into 10 to the power 3. To indicate long decimal, we use powers of 10 with negative exponents. For example, 0.00000 then 62. This becomes 62 into 10 to the power minus 7. Here I am concluding the number system. I tried my best to make you understand the concept of it. For your further reference, go through books, for example, practice and question and answer and understand. I don't want to make a long video for your convenience. My third volume will be on algebra, and then forthcoming video for geometry, and last one is data and graph. If anything wrong is gone in my video, please help me to give a suggestion, so that I may not do wrongly in my next video. For that, I will be very much thankful to you all, my viewers.